Hi everyone, this is the second part of the exponent rules. Today we're going to learn a few more examples and look at some complicated types of examples for exponent rules. So you already learned how to do adding exponents, subtracting exponents when you divide, and also looking at how to make a negative exponent positive by flipping it. So today we're going to learn when you would multiply exponents. So here, power of power rules is if you take a power and you raise it to another power, then you multiply powers. So here, A isn't the difference between yesterday or the previous lesson was that you had a to the m times a to the n. And you said that that was a to the m plus n. That was the old way. This is new because we're doing a to the m to the nth power. So then here we multiply. So you're going to multiply m times n. So if raising a power to a power, multiply the exponents. So here, the example here is if you had x squared to the 8th power, that would be 2 times 8 is 16, so x to the 16th power. And the reason behind that is if you took x squared and wrote it out 8 times as x squared times x squared times x squared. So 1, 2, 3, 4, 5, 6, 7, and then one more time. And then if you follow the addition rule where you would then add 2, 4, 6, 8, 10, 12, 14, 16, you would get x to the 16th. So that's where this rule comes from. So let's go ahead and practice with it. So y to the negative third to the negative fourth. You'd multiply negative 3 and negative 4 to be positive 12. So y to the 12th. All right, here you do 2 times 5, it'd be 10. So negative 6 to the 10th. But remember from the last lesson is that you can't write parentheses in your final answer. So we would have to decide if this is positive or negative. Since the exponent is even, this would come out to be positive 6 to the 10th power. For number 3. So for number 3, you're going to just take 6 times 2, which would be 12. So y plus 2 to the 12th power, and then that's it. You're not going to try to distribute the 12 or anything. You're just going to write it like that. Because actually, this means y plus 2, the quantity y plus 2 to the 12th means y plus 2 times y plus 2 times y plus 2 12 times, and then we're going to learn in another unit how we would multiply that out. Well, not a complicated example like this, but don't worry about that for now. All right, so here's some practice. Which expression is equivalent to negative 9 to the 6th? So let's work out all of these examples. So this would be negative 9 to the 5th because you're adding. This one would be negative 9 to the 6th. This one you would multiply. So this one would be negative 9 to the 8th. And then this one you would multiply again, so it'd be negative 9 to the 9th. So B would be the answer. Next rule, power of a product. So this, for questions like this, when you have a times b in parentheses and they're being multiplied, then you do distribute the m. The difference between that and the example from the previous page is that there was an addition sign here. So if there's addition or subtraction in the parentheses, then you don't distribute the exponent. But if it's just multiplication or division, then you do distribute the exponent. So find the power of each factor in the parentheses and multiply. So here you're doing 4 x to the third times y z all to the third power. So we're going to take 4 to the third power, and then we're going to take x. Now x will now be to the 9th power because you're doing 3 times 3. And then y and z are to the first power, and 1 times 3 is just 3. So y to the third, z to the third. You could simplify 4 to the third. 16 times 4 times 4 is 16. 16 times 4 is 64. So this would be 64 x to the 9th, y to the 3rd, z to the 3rd. All right, this question, number 1. Oh, there are a couple different options that we could do here. So one thing we could do is to make actually the first thing that would probably make the most sense is to distribute the negative exponent in here, the negative 2. So it'd be 7 to the negative 2nd times x to the negative 2nd, and then times y to the positive 4th, because you have negative 2 times negative 2. Now, you can't have negative exponents, so we're going to need to put all of our expression over 1, and then whatever has a negative exponent, we're going to move to the denominator. So 7 has a negative exponent, so I'm just going to rewrite this with 7 squared in the denominator. X has a negative exponent, so that's going to go in the denominator. But y does not, so y is going to stay. Right, so then you can simplify it as y to the 4th over 49 x squared. All right, number 2. So we're going to distribute the negative, distribute the 2 in the parentheses. Now, what do you do with the negative sign here in this case? Now, since the negative sign is in the parentheses, and notice that in number 3, it's not in parentheses, but since it is in the parentheses, that means it gets squared. It gets raised to the second power. Since it's being raised to an even power, it's going to go away because negative times negative is a positive. So you're not going to have a negative sign anymore. You're just going to have 4 squared times z squared, which is 16 z squared. Now, number 3, the tricky part is for number 3, the negative sign is not in parentheses, so it's not being raised to the second power. It's just kind of a negative sign out in front. So it actually stays. So this would be negative 16 z squared. So be really careful when you see a negative sign and whether or not it's in the parentheses or not in parentheses, whether it's being raised to the exponent or not. Okay, number 4. So for number 4, one other option that you have is before you raise everything to the negative second power is you can flip them. However, what I would do first is I would actually go ahead and distribute the negative into the negative 2 into each term in here, because that's going to also make these positive because you're going to multiply 2 negatives. However, you see the z to the 0th power, that's just going to be 1. So we don't need to do anything with that. So we'll do 6 to the negative 2nd, x to the positive 12, and then y to the positive 14. Now, since 6 has a negative exponent in it, we have to move it to the denominator as 6 squared, and 6 squared is just 36. So then that will be our final answer. For number 5, I believe what they want you to do here is do 23 to the 5th and then times 17 to the 5th. I think that's all that it wants you to do there. Yep. All right, and then for number 6, so we're a couple things we need to do. First, we need to get rid of the parentheses by distributing the square into the 2 and the x. So we'll do 2 squared is 4, and then x to the 3rd to the 2nd would be x to the 6th because you multiply, times x to the 4th. Now, since you're multiplying the powers, you add the exponents. So 6 plus 4 would be 10. And then that's it. But more examples. So 2 more of these examples, and then we'll move on to the next type of example. All right, so here you've got negative in parentheses, m to the 4th squared. The negative sign is going to go away because you're raising it to an even power. So this would be m to the 8th times m to the 3rd, which is m to the 11th. All right, over here, this negative sign is going to cancel. 10 squared is 100, and then n squared. However, this negative sign is going to stay because it's being raised to an odd power and it's in parentheses. So the negative sign here will stay as -4. Now, one thing you can do then is if you have this negative sign left over, is you can put it just in the front of the expression. So negative, and then we'll do 4 to the third, and then times n. 3 times 3 is 9. So times n to the 9th. All right, so 4 to the third we know is 64. So then you would multiply 164 to be 640, 6,400. So you'd have multiply those two, so it'd be negative 6,400. And then you will multiply your n. So n squared times n to the 9th would be n to the 11th, because you add the exponents when you multiply powers. All right, so that is all for those types of examples. And we've got one more type, is the power of a quotient. So kind of like the power of a power, all you need to do is distribute this m into all of the terms that are inside of the parentheses. So this is where examples get a little bit harder. Okay, so make sure you take your time and go nice and slow. So here for number 1, you have 3 to the 5th squared. So you're going to do 3 squared and 5 squared, which would be 9 over 25. For number 2, you do 2 squared, which is 4, a to the 5th squared, which would be a to the 10th, and then b to the 7th squared, which would be b to the 14th. And then there's nothing else to simplify or reduce, so that would be your final answer. For number 3, we're going to do everything raised to the 3rd power. So 3 to the 3rd power is 27. A to the -4th to the 3rd power is a to the -12th. Thinking ahead that we're going to have to move that to the denominator. And then b to the 7th to the 3rd power would be b to the 21st. Now, like I just said, since this guy is negative, we need to move it to the denominator with b. So it's going to be 27 alone in the numerator over a to the 12th times b to the 21st. Okay, next line of examples. All right, these look pretty complicated, so we'll take our time here. So multiply all of your powers by all of your exponents by -6. So this would be, the nice thing about this is this in -2, -5, -11 are all being multiplied by -6. There's not going to be any negatives left in the exponents. So this would be a to the 12th, b to the 30th, over c to the 66th. And I know that it looks complicated, but that's all. We don't need to do anything else to that. All right, number 5. So look up here, number 5, how only the numerator is being multiplied or being raised to the 5th power. The denominator is not part of that 5th power thing. So we're just going to take the numerator here. So 2 to the 3rd to the 5th is 2 to the 15th. And then y to the 10th, 2 times 5 is 10. And then 2 to the 10th, y to the 16th. Okay, now we need to reduce. Now remember what I've said in other videos, or in the last video, is that when you are reducing here, is to think about subtracting your exponents, but then keep the result in the numerator or denominator, depending on which one is bigger. So since 2 to the 15th is bigger than 2 to the 10th, it's going to get rid of all of these 2 to the 10ths, and then we'll only have 5 left up here in the numerator. So 2 to the 5th is left in the numerator. And here we have y to the 10th in the numerator, y to the 16th in the denominator. So these 10 y's are going to cancel, and you're going to have 6 left in the denominator. So that's the easiest way to figure that out. And then you can leave it like that, or 2 to the 5th is 32. So 32 over y to the 6th. Number 6. So let's go ahead and distribute the -4 into each exponent. So it would be p to the +16th q to the negative 4th over r to the positive 12th. Since q has a negative exponent, we move it to the denominator. So p to the 16th over r to the 12th, q to the 4th. And that would be that final answer. All right, we have 3 more complicated examples, and then we'll be done. Number 7. So brace yourselves. Let's get rid of these parentheses by distributing the 3 exponent. So we'll do 2 to the 3rd, x to the 9th, over y to the 3rd. And then we're multiplying that by 1 over 6x to the 3rd. All right, so I'm just going to multiply all these together, okay, across. So 2 to the 3rd is 8, x to the 9th, over, and then here, y to the 3rd times 6x to the 3rd. I'm going to write the 6x to the 3rd first, and then y to the 3rd. Right now here, 8 over 6 simplifies to 4 over 3. And then for the x's, these 3 x's will cancel with 3 x's up here and with only 6 left. So then your final answer is 4 x to the 6th over 3 y to the 3rd. For number 8, we're going to cancel this negative sign since it's being raised to the 2nd power, since it's being squared. And then 5 squared is 25 over x squared. And then here, 2 squared is 4. And then 4 times 2 is 8. 3 times 2 is 6. Okay, and then multiply across. So 25 times 4 is 100. Now I'm kind of anticipating here of doing x to the 8th divided by x squared. So these x's, 2 x's are going to cancel with 2 x's up here with only 6 left. So we're actually just going to have 100 x to the 6th over y to the 6th. We can't simplify or combine anything else, so that would be our answer. All right, one more crazy example, I promise. This is the last one. So 3 to the 3rd is 27. Actually, hold on a second. Before we do anything, let's look at what we can reduce first, because I see x to the 3rd over x squared. These 2 x's are going to cancel with only 1 x left up here. So then you're going to just have 3xy to the 3rd. And then here, this y will cancel with one of these y's. So you'll have y x to the 4th over 5 squared. All right, then let's distribute the exponent. So this would be 27 x to the 3rd, y to the 3rd, and then over 1 times y squared times x to the 8th over 5. Okay, if I combine everything then, we're going to have 27, and then we add exponents when we multiply them. So this would be x to the 11th and y to the 5th all over 5. Wait a minute, I did something wrong. I got to do 5 squared, which would be 25. Sorry about that. All right, breath of fresh air now. That is the last example. These definitely are the harder ones, which would be more likely to see as a bonus question. So that should give you some relief, but make sure that you do the exit ticket in Polaris, and then you'll do your Edulastic assignment the next day. All right, have a great day, everyone.